some experiments. What are we doing today? Well, I've got a flask on here that's full of universal indicator. It's colored red because the pH of the solution is indeed red. And I'm going to go ahead and start adding a little bit of base to this. All right, here we go. What I got? Acid over here. Let's add the base here. Sodium hydroxide base. Let's see what happens when I start adding. There's a drop. There's a second drop. There's a third drop. I certainly see a line of blue color developing. It's kind of pretty. Yeah. So that violet color you're seeing is because the pH is changing to 10. The red up here, you know, your pH is 3. That's a difference in pH is 7. Because the pH scale works on powers of 10, that's actually a difference in acidity of 10 times 10, 7 times. Well, that's 10 million. Well, now it's kind of like looking a little bit like an aqua or green. So down there at the bottom, it's become neutral. pH 7 is going to be neutral. As the acid and base react, they will neutralize each other. They indeed will neutralize each other. Try to just get this a little bit different angle here. All right, let's start adding a little bit more base. A couple more drops here right in the middle. 1, 2, 3. That blue color that you see growing in is telling us, of course, that the pH is rising. pH 10. Some beautiful flow patterns we see. That's pretty. Thanks there, Twistianity. Appreciate that. From your name, it makes me wonder if you kind of like tornadoes or cyclones. I'm adding a little bit of acid up there at the top right now. That's why you'll see that red color growing in. It's just a beautiful patterns that we see in this particular flask. If you're new to the live, what we do here is we just hang out. We watch the beauty of this experiment, which is I've just placed some universal indicator into a very large flask. This flask is like 1.5 gallons of volume. And then universal indicator changes color depending upon pH, which is how acidic or basic something is. It follows the colors of the rainbow, with 3 being the most acidic, pH 3 being the most acidic. And thanks, Sarah Shrey. And pH 10 being the most basic, where 7 is going to be neutral. And there's times when, you know, there's regions of all different pH values in the flask. Let's go ahead and add a little bit more acid here. Try to get some red color to develop. And I'm going to add a few drops of base around the outside. No, maybe I'll just chase it with base. Here we go. Look at that. Come on, that's gorgeous. That is just some beautiful color that's growing in there. Absolutely beautiful. Yeah, if we get enough folks in the live, I'm going to do a secondary experiment today, the color separation experiment. That's kind of fun, if you've seen that before. Right now, all I'm doing is I'm adding acid or base. Let's see, right now I'm adding base, sodium hydroxide base, to a container, 1.5 gallon container that contains universal indicator. And universal indicator changes color depending upon pH, which is how acidic or basic something that is. Thank you there, Shrey. And you can see here the different colors that you'll see at the different pH values. So, you know, down here at the bottom, it's violet. It's going to be violet down here at the bottom. And that violet color tells you that it's pH 10. Well, actually, it's violet all the way through, isn't it? Let's start adding some other colors here, or excuse me, some acid here to develop some other colors. So as I add acid, the base will be neutralized, which will pull the pH down. And if I add an excess of acid, then we might see some of the orange, red, and yellow colors. So in goes make sure I'm adding it. Yep, this is the acid that I'm adding. I add hydrochloric acid, which is the same acid that's found in your stomach, except this stuff is like 100 to 1,000 times more concentrated than the acid you find in your stomach. So that's the basic idea of the experiments that we do. And then we just hang out and talk. Like I said, if I get enough folks in here, we'll try a secondary experiment, a color separation experiment that's kind of fun. I do that every once in a while. I have the materials ready for it today. Kansas hates liquids and solids. I assume you mean studying about them. What's up, Supra? Thank you. I appreciate that. Glad you think it's interesting. I do too. I think it's actually kind of beautiful. Let's add a little bit of base. Remember, the base will develop the blue and violet color, and the acid's going to generate your more red colors. And so when we're seeing both in the flask at the same time, like we are now, that tells us that, well, not now. Here, I'm going to add some acid. You can see in the center of the vortex is turning red where I added the acid. Thanks there, Super. I appreciate that. Thanks there, Shrey. Cool stuff. Very cool stuff. This is a really large flask. So if you've seen the live before, this flask is much larger than what I normally use. Here's the normal size flask. That's about a quart. So that flask I'm sticking down there, that's about a quart. So, this is a really big container here. Thanks, Air Moist. I think they are some interestingly beautiful colors as well. I'm going to start adding some acid. Remember, the acid will lower the pH. These are the pH values that you can expect to see. The different colors. And, of course, as I add acid, it drops. Pretty nice, huh? We got it down to a low pH. Down to a low pH. Let's start adding a little bit of base here. You can start seeing some interesting flow patterns growing in with the base. Beautiful stuff. Thank you there, Shrey. Start adding some acid. A couple drops of acid. Oh, that's really pretty. Moist, I don't know. This is just a chemistry experiment that I do. All I'm doing is I'm adding. Okay, the indicator I'm using, Shrey, is called Universal Indicator. All right, it's Universal Indicator. I bought it from Ward Science. You can see that right there. I'm not selling it, but it's just where I bought it. And Universal Indicator is a mixture of 4 different indicators. All 4 of them display different colors at different pH values. Hey, Victoria, how are you? So these are the different indicators that are used. There's thymol blue, which shows, the lion's share of the colors. You mix in a little methyl red. I can't do that, systemic. Mix in a little bromothymol blue, mix in some phenolphthalein. Together you get the universal indicator. How you doing there, one chemist? Yeah, this is just water. So it's just water, but to the water I've added some universal indicator. The different dyes. And those dyes change color depending upon pH or how acidic or basic something is. So right now I'm adding acid at the top. And that's going to cause shifts to red, oranges, and yellow. Yeah, that's what you can call it, Shrey, the ultimate indicator. I'm going to start adding some base now because we're getting a nice color, red color developing. I'm chasing it with a bit of base. I'm doing all right, one chemist. Thank you there, Supra. And it is beautiful when you get the entire rainbow of colors showing up at the same time. That's kind of my favorite. Right now it's a bunch of violet, so I'm going to add a bunch of acid right now. There we go. Hey, come on, man. Holy cow. El Shingun, I apologize if I'm not saying your name right, but it looks like they gifted people a membership to my channel. Come on, man. Come on, man. That's well appreciated. And, folks, send El Shingun some love for gifting you a membership. That's really nice. Looks like Peter, DTA, Bejeweled, Bang, Cole, Laura, Dale, Bree, Earthy, King, the Great Macedonian, Spectrophonic, Rob, Bryce, Mr. Chippy, Jason, Joe, Sarada, Joyous Joy, and David. Thanks there, El Shingon, and I apologize if I'm not saying your name correctly. They mentioned thank you for your educational content. Well, thank you. Thanks for the gift. I appreciate that. Hello there, UK. How's it going? We're adding a little acid there at the top. See if we can't get rid of this violet color. There we go. In goes the red. Let's chase it with a bit of base up at the top. We're going to try to keep these colors going. I'm taking a screenshot of that El Shingun. All right, I'm taking a screenshot of that so I can send that to my family to let them know that you provided some memberships to folks. That's really nice. All right, let's add a little bit more acid here. Where colors are kind of falling behind there a bit. Hey, we got 51 here in the stream. We double that. I got another experiment ready to go. We're going to do the color separation. We do the food dye separation, if you've seen that before. It's a very interesting experiment. Malik, I hope it goes well, and I wish you a lot of motivation to study. I need motivation to write a test right now. That's what I should be doing, but I'll have to do that later. We're going to keep these colors going here. Yeah, if you're new to the live and you haven't seen this before, gosh, look at those gorgeous colors. What we're doing is we just do a really simple science experiment. We talk. What the science experiment is I just add some universal indicator to a big flask of water. This is about a quart size here. So you can see this is roughly 1.5 gallons. It's huge. And to that water, I add some universal indicator. Yeah, I got to write an exam, a chemistry exam. So here we go. As I add acid to the universal indicator, we're going to see that violet color change to a red. Because what's going on is there's an acid-base reaction. The acid is neutralizing the base. And if they perfectly neutralize each other, we'll get a pH 7, which is neutral. So you can see some flecks of where the container, the stuff in the container is neutral. But I think there's a bit more base in here. I'm going to keep adding a bit of acid here. Let's go like 3 more drops and see what happens. What's going on, NRM? Oh, that's really nice, Malik. Great to hear it. You got it, Shrey. Shrey has done a good job encapsulating the experiment. We basically changed the pH in the flask from low to high, high to low. Low means higher acidity. Low pH is, thank you there, Colin. I appreciate the subscription. So yeah, the lower pH values mean higher acidity. Can you make an iron acetate complex? Well, the video I just put out this weekend, I think it's an iron nitrate complex I end up making out of a metal. It's supposed to be a coin, but it's really a token. You might want to check that out. It's pretty interesting. Malik, this is not dilute acid. It is 20% by weight hydrochloric acid, which is fairly concentrated. That's why I'm wearing gloves. But, as soon as I stick it in, it's like 1.5 gallons of water. It's diluted tremendously. Guys ready to see another experiment? You guys want to do another experiment? You want to do the color separation experiment? I've got that ready to go for you if you want. Trey's saying yeah. Oh, just stepped on a cup. See if any other folks want to do the secondary experiment. Let's go ahead and do it. What the heck? I got one ready here. So let me get this ready for you. We'll pull this out. I'm going to have to readjust the camera so that we can, look how tiny this bottle is in comparison to the... Can I do a precipitation reaction? I can, but I don't have it ready for you. So sorry about that, Malik. I do not have materials ready for a precipitation reaction. Let me get this big honking thing off of here for a bit. Here, let me make it acidic first. I always usually make it acidic when I store it. And we may come back to this. All right, a bunch of acid in there. Let's see what happens as that moves through. Gorgeous. Gorgeous color changing. Very nice. Okay, I've acidified that. Oh, that's big. Man, is that big. Okay. Oh. We'll turn this off. Thank you there, Shrey. All right, we've got this bottle here. All right. And I am going to, hey, we got someone from Turkey in the chat. Ubaid. Sorry if I'm saying your name wrong, or Ubaid. I know I'm probably not saying that correctly. So there we go. Here, let me just do this. I'm gonna have to just adjust the camera here just a bit so we can focus in on this particular experiment, which you're gonna love if you've not seen it before. It's gonna use blue food dye and yellow food dye. And we're gonna put that blue food dye and yellow food dye into this liquid. Ubed, okay, thank you. All right, I'm gonna move this out of the way, and I'm going to move this light here so we can get some nice bright background lighting. It's gonna make everything look nicer. Okay, try to just straighten it up just a bit. Hey, we got someone from Saskatchewan. Hi, welcome to my neighbor up north. Sorry that we're, I don't want to get into it, but I apologize for what my country's doing. Okay, here we go. We're going to go ahead and we're going to add a drop of blue food coloring to this liquid. In goes one drop. I just think that's gorgeous, the way the liquid. Hey, we got someone from Utah coming in. Great to hear. Look at how gorgeous that looks, huh? I mean, even just a drop of blue food dye in this particular liquid is absolutely gorgeous. We'll get through it. Yep. Yes, we will. Thank you. I appreciate that. I really do. I really do. Thanks there, Dennis. I appreciate that. Hey, we got someone from the United Kingdom. That's awesome. Awesome. Hey, Malik from India. Wow, we got folks from all over the world here, which is just fantastic. Okay, another drop here. Aha, Frequency and Vibes asked the right question. What is the liquid? So I'm going to answer that since you've asked. It is a mixture of isopropyl alcohol and water. So up here at the top, you can see I'm going to add in a drop of yellow food dye now. In it goes. Hey, someone from the Caribbean. Archangelaza. I apologize. I know I'm Archangelaza. I'm guessing. Feel free to. Hey, we got NRM from Iraq. Awesome. Welcome aboard, everybody. We got humanity from all over the place. I'm loving it. Okay. So, we've got our bottle here. I'm now going to mix it up. All right. Let's mix this up. Of course, if you got blue and you got yellow together in a flask, it's no surprise that when you mix it up, what you see is green. That's not a surprise to anybody, of course. That's exactly what we'd expect to see. Now what I'm going to do, though, is I'm going to add a white solid. It's called sodium carbonate. I'm going to add this white solid to this green flask, okay? And then we're going to talk about what happens. You tell me what you see, and then we're going to try to describe what we see using some chemical knowledge. Here we go. So in goes. Thank you there, El Shingan. Here we go. We're going to add in the white solid. In it goes. Quite a bit to add. In goes the white solid into the green fluid. If you've been watching, you know what the green fluid is. It's a mixture of water, isopropyl alcohol. Curses, some of this. I got to get a little bit more in here. It's water, isopropyl alcohol, blue food dye, and green food dye. I just got a little bit of stuff spilled here. Hold on. Let's get her in there. There we go. I think that's all of it. Okay. Still didn't get it all in. It's getting blocked. We got to get all that in there. It's just the right amount of solid for the trick. All right, one more try. Here we go. Come on, get it all in there. Get it all in there. Something is trapping it. One more shot. Getting close. In goes the white solid into our green liquid. It's a slow process. All right, it's in. Let's shake this baby up. Forgive me for not reading the comments right now. I'm focusing on the experiment, trying not to mess things up too much here. As I'm shaking, I'll be able to read. Yes, there is a very cool group of folks here from all over the world. NRM, I wish you a lot of motivation in your studying for your exam. Thank you there, one chemist. So I am dissolving into this green fluid a white solid. The white solid is sodium carbonate. The green fluid actually has 4 components. The 4 components in the green fluid are blue food dye, yellow food dye, water, and isopropyl alcohol. And I think I might need to get a bit more white solid in there. Let's just see. I'm going to just let this set, and we're going to find out if it's working. How much? Yeah, it's definitely working. So what you're noticing here, tell me what you're noticing. Come on, it's beautiful. It's so cool. It is so cool. That green fluid is separating, isn't it? It's separating into a blue fluid on top and a yellow fluid on bottom. Huh, funny NRM. So what the heck is going on in that experiment? Well, you might remember that I added yellow food dye, I added blue food dye, and there was also alcohol and water. So one simple way to think about it, potassium permanganate and ascorbic acid is an interesting reaction. Oh yeah, it's definitely just a separation, and what we have here is an alcohol layer on top that contains the blue dye, and a salt water layer, it's sodium carbonate water layer, down here on the bottom, that contains the yellow dye. Let's shake it up one more time and see if it re-separates. Okay, of course you shake it up, the blue and the yellow combine. See if it'll actually separate. Absolutely, Shrey. It's kind of exactly how oil and water are separated. It's not just density, though. It's not just density. It also has to do with the way the ions in the salt and the molecules in the alcohol and the molecules in the water attract one another. It works like this. At the start, we had an interaction. Boy, it's really looking nice right now. That separation is just looking gorgeous. At the beginning, we had alcohol and water. And the alcohol and water were mixed because they had some attraction for one another. Those molecules were attracted to one another. But the attraction was, we'll just say, tenuous, kind of weak. It was there, but it was kind of like, a couple that's, they're together, but they don't really know if they're in love or not. Then what we do to that mixture is we added some of the salt. Let me shake it up again, okay? And when you add the salt, well, the salt dissolves into ions, and those ions love the water. They absolutely love the water. And the water loves the salt, and because of that, they attract each other very strongly. And just like when two people fall deeply into love, they sometimes decide to date each other or love each other exclusively. And so what happens is the salt ions in the water are so strongly attracted that they push the alcohol out. The alcohol just doesn't have the attraction anymore to overcome the strength of attraction between the ions and the salt in the water. And it turns out that the yellow dye happens to like the salt water layer better, and the blue dye happens to like the alcohol layer better. And that's what's going on in that experiment. Yeah, we can try that. So NRM asks, okay, here, there's a bunch of questions. Let me try to get to them here, okay? So let's see. How much percent alcohol is there? Okay, Malik, here's what you do. You're going to get 70% isopropyl alcohol, all right? You're going to get a 50-50 mixture of water and this 70% isopropyl alcohol. And you mix that together. And it's about a cup each, so that's about 250 milliliters each, okay? About 250 milliliters of water and 250 milliliters of this 50% isopropyl alcohol. And then you're going to add, you know, your yellow food dye, your blue food dye, and then you're going to add 50 grams of sodium carbonate. And let me show you where I get the sodium carbonate. Then I'll read through some more of these comments here. All right. This is where I get my sodium carbonate. Laundry Booster, Super Washing Soda, Arm & Hammer. That's where I get it from. All right. NRM wants to know if we can add more colors. We're going to try that NRM because I have a second one. Here's a fun, simple reaction here. I'll mix this up while I'm reading here. Mix sulfuric acid and potassium permanganate and touch a cotton swab to it. That sounds like a lot of fun. That sounds like a lot of fun, gaming. I might have to try that. Yes, it will work every time I shake the bottle. How to prepare hydrochloric acid at home. I usually just go to the hardware store and buy drain cleaner that has HCl. Permanganate. Ooh, that's manganese 4 oxide and hydrogen peroxide. Let's have a question. Is tin 4 the only real 4+ metallic ion? No, there are several other +4 ions, like lead. Lead is another ion that goes +4. Ah, I see what you're saying, though. Yeah, one chemist. I apologize. I don't happen to know off the top of my head if lead 4 goes covalent or not. I just always assume if it's an ion, it goes ionic, but I'm not getting into the, you know, the major details of the chemistry. Okay, we're going to try this again. We're going to do this experiment again, but instead of using blue, we're going to use some other colors, okay? How did I feel, Shrey? It feels like a puff of cold air when you put your hand in liquid nitrogen. All right, let me get a couple more colors over here, and you guys tell me which one we're going to try. Let me see if I can find them. Man. Well, folks, this is all I got. I don't have any real interesting colors. I got some neon colors we can try. It looks like I got neon pink. Let's try neon purple. I got neon purple. I think this one works pretty well. We're going to try this one, okay? We're just going to try it. I think this does something interesting. If not, I'll just add a second color and we'll goof around with it, okay? So let's repeat this experiment. Thanks for the translation. Appreciate that. Okay, here we go. We're going to set up this experiment again. I've got a mixture of 70% isopropyl alcohol and water. Here it is. We're going to add a drop of neon purple food dye. If you look very carefully, you can see that there's like an alcohol layer on top of a water layer in this container. Here goes the drop of neon. Oh, look at that. Look at that gorgeousness. Look at the food dye just going down in there. Just pretty. Absolutely gorgeous the way that mixes in. Isn't it? Look at that. It's just a thing of beauty. I agree, Shrey. I think we're going to give this a shot, okay? You can actually see it now. So you can see kind of the alcohol layer here. The dye is not going any deeper because this is sort of the amount of alcohol that I added. And then you can see the water layer here. The dye just kind of stops there at the interface between the two. All right? But if I mix it up, if I, cap it off. Where's the cap? Where's my cap? Curses. Where'd I stick my cap? I need a cap for this. Dadgummit. Well, where's the other bottle? That'll work. Let's just use the other lid. Sorry, y'all. I can't seem to find what I'm looking for here. Here it is. Oh, it's right over here on my left. Okay. All right, here we go. We're going to add the lid to this. All right, so to recap, what's in this bottle? What's in this bottle is a drop of neon purple food dye. There's some alcohol that I poured on top of some water. And if I mix this up, we see that everything mixes perfectly. So the dye mixes very well throughout the mixture of alcohol and water. I think I'm going to add one more drop of dye. I just want a bit more color in this. All right, so here goes another drop of the dye. We can actually tell that this indeed... Oh, that's pretty. Man, is that pretty. And this time we probably will see the dye go all the way down to the bottom because, you know, the fluid is homogenized in this case. Sure enough. So you can tell in this case that the water and the alcohol had been thoroughly mixed. We don't have that separation that we did last time. All right, let me go ahead and mix this up. And then we're going to add our white solid. And we're going to see what happens. Because I forgot who it was. Let me go back and look. I think it was somebody who had 3 letters for their name. Because NRM asked to try this with a different color. All right, so Legendary Killstreak has asked, hey, I haven't been here in a while. What are we doing today? Well, what I'm doing today is I've taken a mixture of isopropyl alcohol and water, and to that mixture of isopropyl alcohol and water, I have added 2 drops of neon purple food coloring. So I added this stuff, neon purple food coloring. And now, to this mixture, I'm going to add some sodium carbonate, which I get in the laundry section of my grocery store. It's called Super Washing Soda, Arm & Hammer Super Washing Soda. So here we go. In goes the white solid. And we're going to see what happens. I don't know what's going to happen because I've not done this color before. And we got a blockage, which happens. I hate it when the blockage happens. I don't know why the blockage happens. Hold on a bit. Okay. You know what? I'm just going to try to pour it in like this. Hopefully I can aim it in. All right, in goes the super washing soda. Hopefully I won't spill it. Ooh, baby. In it goes. So again, what I'm doing is I'm adding sodium carbonate to a liquid that contains water, alcohol, and neon purple food dye. All right, here we go. Let's cap it off and shake it up, and let's see what happens, all right? Now remember, when I do this, the ions in the salt dissolve in the water, and there is going to be a very strong attraction between the water molecules and the ions from the salt. And that attraction is going to be so strong that it's going to push the alcohol out. I like to make the analogy like when 2 people fall in love and they love each other so much that they date exclusively, or they decide for the rest of their lives they're just going to be with each other. That's kind of like what's going on with the salt and the water right now. And there's just not room for anybody else. And so that means that the alcohol is going to get pushed out. And it looks like it's not only alcohol that's getting pushed out, it also looks like the violet dye is as well. Can you see it? Can you see it? You can see down here at the bottom that the dye is not going into the water layer, it's going into the alcohol layer. No, this will not cause electricity. Thanks, ham and cheese. Sorry about that, Alex. Appreciate that, event star. So yeah, there you have it. I'll shake it up one more time. Let's shake this up another time and see if it re-separates. Try to get that purple color into the saltwater layer. I just don't think it's going to go, right? The salt and the water are too attracted to each other. Thank you there, Legendary. Thank you there, Artina. I appreciate that. Thanks for all the hearts. I see them down there. I see those hearts piling through. Those are very nice. Yeah, it's really nice to see. You can like see the three different layers. So you can actually see three different layers. We call this layer the salt water layer. This layer up here is the alcohol layer, and then in between there's a third layer. You can see it's got a different shade than this violet up here. And in this layer, the salt water and the alcohol layer, they're mixed, but it's a transient mixture. You can watch it shrink over time. And these types of layers like this that are transient, we call them an emulsion. So this is the emulsion layer, and you can watch that emulsion layer shrink over time. Event, I'm sorry, I didn't know how else to explain it. There's not room for anyone else. Now let's watch that emulsion layer. You can just barely see it. Look at it. Isn't that cool up close? It looks like clouds, you know? It looks like clouds. Very cool. So we're going to shake this up again. And then I think I'm going to try to add some, I'm going to add some of the pink food dye to this just to see what happens. We know the yellow is going to go down here, so I'm not going to add any yellow. Yeah, Assad, Adidia, there's a mixture of two acids, mixture of nitric acid and hydrochloric acid. We call that aqua regia. There you go, Alex. There you go, Alex. The chemist has entered the chat. That mixture that dissolves platinum and gold is called aqua regia. Thank you there, Shrey. I think it's a very interesting mixture as well. Oh, interesting. So someone's father did some silk screening. Interesting. I wonder why emulsions are important in silk screening. There you go, Alex. Okay, so we can see the emulsion layer here. We can see the alcohol layer here, and we can see the saltwater layer. I'm going to zoom in on this because I like seeing the top of the emulsion layer. So we're looking at the interface between the alcohol and the emulsion, and that top, to me, it always looks like clouds to me. It's very interesting. So what I'm going to do now, I'm going to add some of this pink. I don't know. We're going to add some of this pink neon food dye. There we go. I'm going to add a couple drops of pink neon food dye, see if we get a little difference, okay? We're just going to add it in. We'll do 2 drops, all right? Thank you there, Frequency and Vibes. Here we go. 2 drops. There they go, of the pink. And I'm expecting that not to penetrate the saltwater layer. And that's because the density of this is just too high for the dye to penetrate that layer. But there may be a dye in the pink that we can actually get to dissolve in the water layer. Let's find out. I'm not sure, but we're going to find out. We're going to mix all this up, and we're going to see what happens. So here we go. We're going to mix together. So what we have now is alcohol, salt water, neon pink, and neon purple food dyes. Let's see what we get. Let's see what we get. To me, I can already see, I don't think the dyes are going into the saltwater layer. It looks colorless down there. We're still getting a nice, interesting color effect, though, yeah? Come on, Shrey. Hey, thanks there, Nick. So, Nick, just to give you an idea of what we're doing, this is just a bottle that contains salt water. It's actually a special type of salt called sodium carbonate and alcohol. And then I'm adding some different dyes to it and seeing if the dyes go in the alcohol layer or the saltwater layer. You also see a third layer here that's a transient mixture of the two. We call that an emulsion. Here's what we got the other time when I did a drop of green and a drop of blue. Excuse me, a drop of yellow and blue. The yellow goes into the water layer. All right, I'm going to now try a drop of neon green food dye just to see what happens. All right? No problem, Nick. Welcome aboard. Glad to have you aboard. Here we go. We're going to add a drop of neon green food dye. I just want to see what happens. See if anything interesting happens. We'll go 2 drops of this. Boop, boop. We're making a mess. Let's see if we get any dye from the green to go into the. Oh, I can see it's going to happen. You can totally see it's happening. You can tell that. Look at that. You can already see it, right? There's some yellow dye that's in the green dye, and we can see it slowly starting to penetrate into the water layer. It looks like, my guess is, because I can see evidence of it happening, when I shake this up, we're going to get a fair amount of yellow dye in the bottom. And that makes sense because, you know, green is going to have some of that yellow dye in it. That's the way they make the yellow dye. Here we go. We'll shake it up. We'll see if I'm full of crap, and we'll see if my prediction is correct. Let's see. Let's see what happens. Oh, thanks, NRM. Oh, it looks like the flag of Indonesia. That's cool. Very easy to see the different colors now. We can see, look at that. The saltwater layer is yellow. We've got the alcohol layer is kind of like, to my eye, like a dirty orange. And the emulsion layer, which is quite large right now, that emulsion layer looks less dirty orange. Boy, you can really easily see the separation in this. Very easy to see the three different colors. Very pretty. Very pretty. Thanks for the hearts. I see them coming through. I appreciate that, everybody. I appreciate the likes. I guess those are likes. I see the hearts coming through, and I appreciate them. Yeah, that's a beautiful experiment. I'm going to shake this up one more time. We're going to look at the layer here. Excuse me, the interface between the emulsion and the alcohol. I agree, Shrey. It is very interesting to see. So, you know, when you shake up a bottle of salad dressing that has oil and, it's basically oil and vinegar, which is basically oil and water, you're making an emulsion. It's just that emulsion separates really quickly. This one takes a while. This one takes quite a bit, as you can see. And I like that because it gives you some time to kind of process what's happening. All right, once that emulsion alcohol interface starts to form, we'll zero in on it and check it out a little better. I can see it right there. Let's see if it looks kind of cloudy. You can see bubbles. You can see air bubbles coming up. Yeah, from the combination of the two. A lot of air bubbles trapped in the emulsion. You see that? And they rise to the surface, and when they hit the interface, they really start to take off. But those air bubbles, for whatever reason, they take a long time to get through the emulsion. It's beautiful. And yeah, the top of the emulsion layer where it interacts with the alcohol, it just gets this cloudy-like appearance. It's like I don't know what it's like. Very cool, huh? Very cool. Yeah, I am, NRM. I am. Thank you there, Michele. Thank you there, Shrey. Thank you, Event. Appreciate that. All right, let's get back to our original experiment for a little bit. It does look a little bit like a watercolor. We'll get back to our original experiment here. Bear with me a second. I've got to lift up this rather large container. Here it is. It's a 1.5 gallons of water. Okay, let me cancel. There we go. Let's get back to it indeed. I'll put these over to the side so we can get that backlighting looking nice. That backlighting really helps make everything pop. All right. Let's get the stir bar going. And once I see that vortex starting to form at the top, we're going to start adding some sodium hydroxide solution. Very large container. Just for comparison, that's a 1/2 liter bottle right there on the side. Okay. So there's my 1/2 liter bottle. Yep. Pretty cool, huh? So I do, my content in YouTube, I do science stuff. So I do science experiments. with a little bit of fun involved. Then goes a couple drops of base. How can we get ethane from ethanol? It is a big container, Shrey. You know, I don't know. You're going to have to reduce it. But I wouldn't know off the top of my head. Probably lithium, what's it? Lithium borohydride, LiBH4. That's funny. That's funny, NRM. All right, let's keep adding some sodium hydroxide base here. Boop, 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 boop. I agree, Shrey. It's just really cool. Something I don't mention a whole lot. Here, let me get everything red here. Let me get the pH pretty low here. I'm going to go ahead and add a bunch of acid. The acid I'm adding is hydrochloric acid, which is the same acid that's found in your stomach. It's just that this stuff is like 100 to 1,000 times more concentrated. What I'm going to do here after this kind of homogenizes to a red color, come on. Let's get everything homogenized. I'm going to turn up the speed just a bit. Get her going. Boy, that's gorgeous. I'm not using hydrogen peroxide, Raul. Not using hydrogen peroxide. Okay, so now we have a homogenized red solution. And what I'll be doing now is I'm going to be adding drops of sodium hydroxide base. I'm going to add it to the center of the vortex. And you'll notice, here we go, I'm going to add one drop. One drop. You'll notice that material tends to stay in the center of the vortex, you know, until it hits the bottom and hits the stir bar, and then the stir bar pushes everything out along the sides. But the reason why that material is staying in the center of the vortex is because, just like the eye of a hurricane has low pressure, the center of this vortex is low pressure. Hey, Ruby, my dog's over here. Hey, girl, how you doing? And material tends not to move out of low pressure towards high pressure. It moves in the opposite direction. And so you're going to see that material tend to stay in the middle because it's in a low pressure region, and material moves from high to low pressure. And if you're already in a low pressure region, you're going to stay put. Boy, that is just a gorgeous rainbow. Man, that is beautiful. And look how long that's persistent. What a beautiful experiment. Man, that's pretty. That is just so pretty. NRM, it's like 5 p.m. here. It is like a whirlpool. Let's add some, I'm going to add some base here again. Like 4 drops. There we go. Get some beautiful structure to the whirlpool. Thank you there, Artina. Thank you there, Event Star. Very pretty. All right, let's add some acid now. So I'm going to add some acid to the center of the vortex. That's 5 drops. Let's see what happens. You can see it got pushed down to the bottom. It's starting to get a little red down there. If you're new to the live, the reason why the colors are changing is because I have added universal indicator to this flask. It's just water. And universal indicator displays different colors at different pH values. If your pH is 7, you're neutral. If your pH is below 7, it's acidic. If your pH is above 7, it's basic. The higher you go above 7, the more basic it is. And the lower you go below 7, the more acidic it is. I'm adding acid right now. And adding acid is going to shift things to red, orange, and yellow colors. Hey, come on, man. El Shigon just gifted some of you some Tommy Technetium membership. So thank you very much, everybody. I appreciate that. God, man, that's just so nice. You do not need to do that, but it's much appreciated. So it looks like El Shingon has gifted some Tommy Technetium memberships to Feel the Joy, Loquacious Primate, Jay Childers, Courtney, Last Shepherd, Henry of the Revolution, Impavidus, Blitzed Boxing, Hashiria, Steve M., Robert Moneygold, and Neptune. Thank you very much. So Nick says they love fountain pens, and that blue reminds them of their favorite ink. It's Bay State Blue by Noodler. Okay, and here you go, Nick. I'm going to add in some base to get the blue color for you, buddy. There you go. El Shingon also gave memberships to Bloodhound, MM, James Smothers, Charlie Kelly, Oyashiro, Michael, Zadaka, not an AFT. Thank you there, El Shingon. Appreciate it. That's very, very kind. Yes. So long, El Shingon. We appreciate the love. Man, big time. You have a great week. Thank you so much for being a part of the live and doing some science experiments, some chemistry with everybody. We had a great time. Oh, I'd love to do that, Manasai. What's going on, Peter? What's going on? We're finishing up the live here pretty soon, I think. I've been going for about 50 minutes, so I don't see myself going much longer. Yep. How you doing, Ruby? My dog's down here. You guys want to see my dog? Here, Ruby. There she is. That's my dog, Ruby. How you doing, big girl? This is Ruby. Isn't she beautiful? She's an old girl. Yeah, give me a kiss, girl. Give me a kiss. Good dog. Good dog. She's such a good dog. She wants to go OUT. She's looking at me. She heard me say that. You know how that works with dogs. Oh, man. Hello, James. Does the indicator ever expire? Yeah, I mean, but it takes a long time. Ah, thanks there, Peter. Thanks there, Peter. Let me give a, yep, so long. So long there, Peter. Let's see, let's add some drops of, So their only problem with chemistry is the long names. Tell me about it, man. It is like its own vocabulary. I guess that's like any discipline, though, right? Any discipline has quite a bit of jargon. At some point, I'm going to go ahead and flip the camera around. Just a fair warning that if you don't want to see an old man in his basement, then it might be time for you to get off the live, because what I normally do at the end of the live, I just flip the camera around and talk to folks. Name an olfactory indicator. Oh, man. Well, I would say amines, monocy, right? Amines, though those are compounds that are found in fish. It's what gives fish, amines give fish the fishy smell. So if something smells fishy, it's often amines that are responsible for that. And this is why we add lemons to fish to get rid of the fishy smell. Because what happens is when you add acid to amines, they become protonated and they're not as volatile. They don't get up into the air where you can inhale them and smell them. And so an olfactory indicator is going to be an amine. Hello there, Zadika. You want to see the dog? You got it. You guys want to see the dog? There she is over there. How you doing, Ruby? How you doing, big girl? You're a good girl. You're a good girl, Ruby. Yeah. NRM, I'm not wishing you luck. I'm wishing you a lot of motivation and clear thinking. That's what I'll wish you. I don't wish students luck. I don't wish anybody luck. I just wish you skill and motivation to do the things that you need to do. That's what I wish, folks. Oh, that's gorgeous. We really got some interesting color changes today. We really did. Oh, that's beautiful. Come on, man. Sure, Gray. Gray's channel wants a shout out. Maybe check out their channel. What kind of things you do on your channel there, Gray? A couple drops there. Monasai, I am adding 20% by weight hydrochloric acid, which I just added. Here, I'll add a couple more drops. And now I'm going to add 20% by weight sodium hydroxide. In goes 2 drops there. Fortnite, you're a Fortniter, huh? Yeah, that's cool. So it looks like Gray, if you like that kind of thing, you like watching somebody play Fortnite, you might want to go check out Gray's channel. All right, let's flip this around. Let's talk to you here for the end of the live. I want to acidify this first. Isai, I recover the chemicals that I'm using right here. So right now I'm acidifying the mixture, because I have found that if I acidify the mixture, lower its pH to around, at least pH 5, that no mold grows in this, and I can just use it over and over and over again. You're welcome, Martina. So yeah, I often try to reuse the chemicals as much as possible. Boy, look at that gorgeous rainbow. I almost hate to make it go red, but I want to be able to use this again, so I'm going to go ahead and just finish it off. Let you watch that as it goes back to red. That is, I added base like an idiot. Let's try to add the acid. Come on, man. I just slowed things down. There we go. Oh, Event, you caught it. All right, I think that's going to be acidified. Let's hang out here. Let's see what's going on. How we all doing? Ensir 100, welcome. What kind of things you do on your channel, Ensir? Good to hear. Good, glad to hear you're doing well. Yeah, these are my reading glasses and my safety glasses, so I can tell what the heck's going on. Thanks, Airman Say. Oh, Bubble, yeah, I always do this at the end. I always talk to folks at the end. Here's the real face reveal. So without the sunglasses, you just see totally what I look like. If you want to know. So yeah, we're just gonna talk. I have to wear these though because I need to read. There's some readers there, so I can read what's on the screen. You're welcome, Event Star. Yeah, Shrey, I did 3 days straight. I did do 3 days straight of streaming. We just had I had one of those weekends where just felt kind of motivated to do it, and I just didn't have much to do, and I enjoy doing this. Michele, I wish you a lot of motivation and a clear thinking. So, well, folks, it was see, my voice is cracking. I've been talking too long. Hey, it's good hanging out with you all today. Thanks for Isai. I have a PhD in chemistry from the University of Michigan. I have a master's degree in chemistry from the University of North Carolina at Greensboro. And I have a bachelor's in chemistry education from a state school in Pennsylvania. So yeah, so I know quite a bit about chemistry. Thank you there, Nick. I appreciate the subscription. I very much appreciate the subscription. Yeah, it's a long road. I mean, I have a long time goal of trying to hit 1 million subscribers. Like all of us YouTubers do, right? That's what we're trying to do, ultimately. We're slowly but surely. I keep clicking on up, so every subscribe that I get, I appreciate greatly. How about you? If you folks feel like it, why don't you drop some of your educational... You think I will, Shrey? We'll see. Yeah, folks, let me know your areas of expertise if you wish. Mine happens to be chemistry and education. Just be interesting to hear what what all of you study, or are studying, or are attempting to study, or want to, what do you want to get your expertise in? Adidia, yeah, I do enjoy organic chemistry, but I have to admit, out of the 5 branches of chemistry, organic is the one that I tend not to gravitate towards. I tend to be a mathematical thinker. Oh, chemical kinetics. I love me some chemical kinetics. So, if I'm a mathematical thinker, you can probably say, okay, this guy likes physical chemistry, that's what I am. I'm a physical chemist. And inorganic chemistry is closely related in some ways to physical chemistry, so I enjoy that. And then biochemistry, come on, man. Biochemistry draws from all branches of chemistry. And so it's very natural. It's a very wonderful thing to study. And then analytical is very mathematical and exacting. And so I like that as well. Oh, Nick does some commercial refrigeration in the United Kingdom. Very cool. Very cool. So, Nick, tell me a little bit about this. One thing we have to worry about with refrigeration are chlorofluorocarbons from a chemist perspective. That's what we're going to ask you about. Did you used to at one time use chlorofluorocarbons, and are you trying to phase those out? What kinds of things are you trying to do? And one of the reasons, there's two reasons why we try to get rid of chlorofluorocarbons. First is because they interact with ozone in the atmosphere, destroying it, and that's what can cause the hole in the ozone layer. So that's one reason why we want to limit the release of chlorofluorocarbons in the atmosphere. And the second reason is that they're greenhouse gases, and they're very powerful greenhouse gases. And the issues with those, right? The greenhouse gases are going to cause, well, they aren't going to cause, they are causing the warming of the planet, and that has a lot of trouble. Artina is studying pharmacy. Waldemar is studying apothecary. Ivanhoe Thumbs grows mushrooms. Let me just tell you this, Ivanhoe. I very much appreciate the work you do. We'll just leave it at that. I assume you mean for cooking, of course. What else we got going on out there? Yep. I see Ivanhoe. It's interesting to hear. The compound in mushrooms. There's quite a few, but there's one called psilocybin. So you do gourmet mushrooms. Okay. We won't mention the compound psilocybin then. That's all I'll say about that. Nice gourmet mushrooms. I love eating mushrooms. They are delicious. Absolutely. I try to eat like a vegetarian. I'll occasionally have meat, but if you're a vegetarian, you go to mushrooms a lot. So, yeah. Well, folks, looks like I've hit over an hour. I see Ivanhoe. Oh, Shrey, let me know when you get to do the gallon stand reaction. I did, Ben. I loved Breaking Bad. I absolutely love that. What a great show. I'm trying to get through Better Call Saul right now. I think I'm just starting season 6. I watch it with my son. So when my son comes home, he's a big film guy, and so when he comes home, we watch that together. So I need to finish the series though. Ben, what do you think of Breaking Bad? Oh, so you don't like Better Call Saul, huh? I'm enjoying it. It's not as good as Breaking Bad, but yeah, I'm absolutely enjoying it. How you doing there, Jacob? Or Jacob, however. Ended too quickly. JBTC likes both the shows. Nice, Ray. Hey, you make sure you drop me a comment, either here in the live or drop me a comment on my gallon stand video. If you actually end up doing the reaction. Yeah, if you like goofy science experiments where you watch a little science, it's kind of cool, and you learn a little something. Sometimes you go a little bit deep into the chemistry, but not too deep. I mean, it's stuff folks can understand. You might want to consider following my channel, Tommy Technetium. Give me a subscribe. Thank you there, Jacob. I appreciate that very much. All right, guys, I'm going to take off. I've been staring at the screen for over an hour. That's enough. My brain's turned a little to mush. Thank you there, Aveno. So Veno gave me a sub and is thanking all chemists for the work that chemists do and scientists in general, helping us understand the world and how we should navigate it, and and the physical things that we interact with. All right, guys. Thanks for hanging out. Remember to check out the beauty of the universe. It's all around you. It's everywhere, man. I mean, like every day, every moment of every day, there's something cool going on. The senses that we have, the feel of a soft pillow or the fur on my dog Ruby as I pet her, or breathing in the air every single time, just all of the crazy stuff that's going on that's just remarkable and fascinating that we really take for granted. It's really hard to try to just be in the moment and notice the beauty that's around us, and we got to share that together here for about an hour today. And so I thank you. I thank you, man. So appreciate it. And thanks there, Shrey. And you all have a great rest of your day, and we'll see you probably next weekend.